Okay, folks, we're back again. I've cleaned the controls here some more. Let's see how we did. Let's see, got sensitivity, we turn that up. Audio, we turn that up. And we're actually picking up a local station here. KELA in Centralia on 1470. Let's put the signal generator on. Again, we're at 473 millivolts, about a half a volt going into it. And there we go. Wow. Let's drop this down a little bit. There we go. The S meter isn't pegged right now. If you hear that, that's pretty doggone good. I think we got most of the grit out of that. The sensitivity control still has grit in it, but it's definitely better than it was. Antenna control works. That's great. And we actually had the CW control working earlier. See if I can turn the modulation off. There we go. And now I'm going to just kick in the BFO here. You can kind of hear that. Not perfect, but you can hear how unstable that is. That needs to be cleaned. Kick the modulation back on. 30%. There we go. And notice right now we're at 15 millivolts. They're just coupling from one to the other. That's not bad. That's right. Put it back into AVC mode, and now all of a sudden the S meter works, as if by magic. There we go. And we can actually tune the antenna. Wow, that brought it way up. We can actually drop this down here. There we go. And what you see there is my signal generator beating with KELA's carrier. If we tune off channel, go up or down 10 kcs, we can zero it back in. It won't be doing that. Okay, I'm going to turn this down for right now. What I wanted to show you here was we're on AC volts right now, 400 volts peak to peak, and right there, AC. I've got one connection to the chassis. Watch what happens when I go to something that's not on here and I go to something that's grounded. Pow, right there. We have, looks to me, about 140 volts peak to peak. So that's about 70 volts AC there. That's pretty stiff. You know, if you come across that, it'll definitely let you know it. Now, if you go over here to where the AC connections are, this is one AC side here. Look at that. And right now we're at, looks to be about 180 volts AC to ground. And if we go here, that one there is about 120 volts AC peak to peak to ground. So you can see what these guys are doing. You got to be careful with that. Also, I've seen those guys explode a few times. If they're paper foils, they probably ought to be replaced. They should be replaced with safety capacitors. Modern caps, I forget if it's the X or the Y designation, but one of them, I believe, will short, or not short, but it'll open up in a failure mode. That way you don't have it dead short and create issues. Okay, this is not bad. If we look down here where the mouse damage was, this is where the nest was down here. The only damage I see is this wire right here. There's a little bit of insulation off it, and that actually goes to the S meter. And then this wire right here, there was a little bit that was chewed on it, but other than that, we're fine. The other really cool thing is that this is a later production radio, so guess what? You have disc capacitors. Not that they don't go bad, but these won't go bad anywhere near as much as paper foils will. So realistically here, if you look, there's a paper foil right here. There's a 0.01400. I would replace that. There's another one stuck behind there. That's a 0.05 at whatever. I would replace it. And here's one across the speaker terminals right there. And I would replace that. And check these guys here out too. And yeah, let's see, a 1955 vintage electrolytic capacitor right there, dry electrolytic. That's probably going to get replaced also. Let's see. I did check the tubes on this, and the deal with the tubes is that about half of them have 1955 dates on them. So I'm going to assume then that a reasonable date of manufacture of this radio would be about the middle to the end of 1955. That's about it. We're going to put this thing back in the case and pop this thing online and get it sold for the estate. Thanks for watching, folks.